Okay, I would like to go over section 1.3, problem number 30, part A. Alright, so there are two functions given. F of x is the square root of 3 minus x, and g of x is square root of x squared minus 1. Then what we want to do is we want to find the function f plus g of x. Alright, so finding the formula is very simple. You just add them up. So f of x plus g, f plus g of x would be just the square root of 3 minus x plus square root of x squared minus 1. Alright, so that's the formula. Alright, the difficult part is finding its domain, right? So let's find the domain of f and g separately. So you can see that the domain of f is going to be, so we're trying to find the domain of f, right? Alright, so since we have a square root, so we have to make sure that the stuff inside the square root must be non-negative, which means that the 3 minus x has to be greater than or equal to 0. So we can just add x to both sides to get the 3 is greater than equal to x, right? Which means that the x has to be less than or equal to 3. So x has to be from negative infinity all the way to 3, including 3. All right, and now we want to find the domain of g, domain of function g. All right, so it's the same kind of drill. You can see that there's a square root, so expression inside the square root must be non-negative. So x squared minus 1 is greater than equal to 0. Right, to solve something like this, since inequality is usually harder than the equality, so I'm going to go ahead and solve the equality version of it. So this is, I'm going to just do equality. So why don't we do x squared minus 1 equals 0. Right, then we can factor out. So this is going to be just x plus 1 times quantity x minus 1 equal to 0. So you can see that x is going to be either plus or minus 1. Right, so that's where this expression right here is going to be 0. So you can think, so maybe I should draw a number line here. Right, so this is where the function is going to be 0. Right, so that guy is 0. Then we have to determine which section we should choose. So we want this expression to be positive, so we'll try any number less than 1. So let's try like a -2. So sample number is -2. So if you plug in -2 into x here, you can see that the -2 squared would be 4, minus 1 is positive 3. So you're going to get a positive sign here, which is what we wanted, because we want greater than equal to 0. If you pick anything between -1 and positive 1, so let's try, so we tried x equals, say, -2 here. So here I'm going to try x equals 0, because 0 is between -1 and positive 1. You can see that if you plug in 0 here, 0 squared minus 1 is -1, so you get a negative sign. Right, so we don't want this section. And let's try anything bigger than 1, so I'll probably try x equals 2. But you can see that the 2 squared minus 1 is 3, so it's going to be positive. Right, So you can see that we have to we want to take anything less than equal to -1 and greater than equal to 1. So the domain of G would be -infinity all the way to -1, including -1, and skip in between, starting from +1 to +infinity. Alright, so those are the domains of function f and g. Right? So the domain of f plus g is going to be the intersection of those two guys. So domain of f plus g is going to be simply the intersection of domain of f and also a domain of g. Right? So which is what? Alright, so we have to, so alright, so it has to be an intersection, so I'm gonna just draw a number line so that it's a little clearer. Alright, so domain of f is less than or equal to 3. So you can see that here 3 is, say, right here, and less than or equal to 3, so we're going this way. Right? But the domain of G is anything greater than equal to 1. So here's 1 right here. So anything greater than equal to 1, or anything less than equal to -1. Right? So it has to be both. So you can see that we can include these guys right here because it's in both, and also these guys right there. So the intersection of those two would be it's going to be -infinity all the way to -1, and also between 1 and 3. Right? So that's the domain of f plus g. Right? Hopefully this was clear.